Hello, welcome to my talk about the graph systems as a way to encapsulate the global state. So let's switch to the slides. Okay, good. So thank you all for coming to my talk. Today I want to tell you about graph system, what it is, how to use it properly, and why I believe you should care. A little bit about myself. My name is Alexey Demidetsky. I'm currently a mobile architect at DraftKings. I spent last 10 years with iOS and Android applications trying to optimize how they build, how we develop them to increase happiness of users, customers, and developers also. Last 5 years I talking about different variations of Redux and Flux, and I try to organize my application state according to these patterns. And I probably see all downsides and uphills of this approach, and graph systems is one of the way to deal with downsides of Redux. Today I will show how exactly. And graph system is not like a fresh idea. It's in production on my team for all over a year now. There are multiple production applications built in with this approach. So I decided to share it with you at this conference. First of all, let's talk about the domain. All the examples that I will show you will round about the domain of displaying the movies. The graph system shine where we have very domain with a lot of components which is tied together. We have relationship between them, so we actually can build a graph which will be connected, not a bunch of isolated screens. But before we will dive deep into the graph system itself, I want to talk about the state management timeline in general. What is the difference between MVC era, Redux, and then how selectors aim to solve some of the Redux problems, and how graph system is improved on the selectors work. So first of all, let's start with state management with MVC. Under MVC, I mean all the general component-driven architecture where all the components live inside the isolated state. So here we can see example of for example, we need to display a list of movies and single movie itself. In default way, it will be two different components with its own isolated state, and maybe some API services will be shared. Maybe they will share database such as core data where some data synchronization can happen, but often it's just two independent screens. So this approach itself, it's has a lot of pros. It's very simple, very local, so we basically can split work on multiple teams. Every team will work on their own controller, on their own component, and will be happy. And it's pretty maintainable because when you need to make change to the behavior of one component, you go to this component and you make a change. No big deal, no synchronization across the team. But with this simplicity comes several cons, several downsides. First of all, it's a duplication of data. When we have same data displayed multiple times in multiple places, we often fall back to download the same data multiple times. So we duplicate the data in memory, and this leads to lack of consistency between data because we need to put extra effort to synchronize all of it. Also, with component comes its life cycle, when it's created, when it's destroyed. So our data, our state is also suffer to this life cycle, and we need to take extra extra preparations to make these issues not affect user experience. The problems derived with using isolated components is that while we have pretty much of isolation, with the component growth and history and development, we receive needs to synchronize the components itself, so they start talk to each other, they start to basically synchronization. And this causes a problem because now changes in one controller can be dangerous to other components. And we want to avoid this because components can change pretty often, and if we'll need to synchronize change across all the system, this will lead to basically a lot of dependencies and often deadlock between teams who develop it. I see this as a problem that all components, they are lacking the common source of truth, so someone who they should believe because otherwise every component in some way in conflict with other component. What is the truth? What I believe or other tell me. So this creates some kind unpredictable behavior inside the components. So usually the common state of truth is achieved using Redux kind of architecture, maybe Flux, but Flux it's basically all the same like Redux, but with multiple states, still multiple sources of truth. Idea is that we introduce a global state. The global state, which just move all the state from the components to some dedicated place, and we design this place accordingly. Just for state management, we change this place accordingly. We can assign a lot of duties to the state, including the notification to all components that something is changed. So components can subscribe to the updates, receive updates, and act accordingly. While components still can interact with API services, the state cannot. So basically, we want to make state like free, functional, without any side effects or any dependencies. How we should design state? I believe that state is best shined when you use table-oriented design or normalized design. So what it is, we'll zoom up a little bit. So inside the state, we want to model real relational database structures like we used to inside the SQL or maybe inside the core data. That we want to create different tables or different like components which will store all entities, for example, all movies, all actors, all something, and separately we want to store some kind of list of IDs. So we're introducing these IDs as a like way to uniquely identify state inside this huge blob. So top movies, for example, will provide a list of IDs. IDs can be not unique because maybe movie will be repeated multiple times, I don't know, and it will have order. So I mean, I can always traverse it in this order, while I need to reference ID and extract movie information from other components. And I can have all kind of useful links from the movies to actors. For a single actor, I know all the movies this actor was spotted by so far, and for single movie, all the actors that was inside this movie so far. So I can have a lot of these tables, a lot of this like components or tables, and in code, I will store them just as multiple of structures inside one big structure state, multiple of components. So while following the table-oriented design, we will model each of this component like inside the table. It will be either the map from the ID to the entity or the list of IDs or something else. Entity itself will of course store a lot of fields. It's nice to notion that we want to use strong identifiers. So every entity should have its own ID, just so compiler can help us to differentiate between those two and will not let us make a mistake and look for something that is not there. Across strong identifiers, also Redux is known for coordinated mutation approach. When we have action which is changed the whole state and we receive new state and response of this action. Usually this is some kind of store in front of the state which coordinates these updates, which try to perform them asynchronously on dedicated queue and manage all the notification observers, all this kind of technical stuff, while the logic itself is stored inside the state. On the code level, mutations of a state is just calling reduce function multiple other functions while passing the state to it. Usually I recommend not to mix and match like aggregation components and logic components. So your reduce should either be set of calling other reduces or switching by action type and trying to perform some logic change something, but not both at the same time. Process of the reduce is well known. It's consistency of state. It's when we can rely on the information stored in state and present it to user, and when it's changed, it's always inconsistent and well-shaped state. Also transparency, we can see and observe all the processes in the state. We have single point of mutation. It's a store function where we can observe all actions. And of course, with this comes the isolation. Every component is isolated, and every component has its own reduce function. Isolation leads that we can extend or change system very with high precision, changing only one component at a time without risking to broke anything else. But of course, it comes with some cons, like everything. First of all, structured entities. While we achieve isolation, now the mental model is not mapped directly to the state. We split it into multiple entities just to optimize storage, just to optimize the reference into those. And it's come with a lot of verbose success patterns, so we need to deal with IDs, and pretty much it's all feel like very low level abstractions. We don't deal with domain data anymore. Now we deal with some kind of single bits of data which we need to compose together. I will show what I mean in a moment. So for example, let's imagine that we want to build this view controller and we want to build the props for it. So how it will look like, this props will contain a list of movies. Every movie will contain 2 strings, title of a movie and top actor for a movie. For those of you who don't know how the props work, it's something like view model for view controller, which has only data and don't have any behavior attached to it. So it's the data that view controller need to show, and we want to basically project the whole state into these props, so view controller will not be dependent on state. We want to make this layer of separation between the UI, between the leaf nodes of our system and the core of our system. Usually it's achieved using something like mapping. So in this picture you can see we have a connector which aims to map from the whole state to the props. It's a simple function without any side effects, so we can test it in unit tests. Well, it's tedious to do, but it's possible. So how it will look like. So for movies, we need to go to the top list and map IDs, and then we need to extract the actors for movies by this ID, and we need to find first actor, and then we need to extract the entity by ID again. So it's a lot of verbose code for very simple operation. Actually, we want to just project something from state to a props, and we need to write a lot of this verbose code dealing with low level and performing logic. For example, full name, it's first name, last name. Well, this logic might be duplicated across different connectors, and we don't want to do this. As you can see, also we have a lot of IDs. So this means that how we structure our state is actually affecting our topmost layer, almost topmost layer. It's not affecting the props, but it is affecting the UI. As a problem, I see in general that we have lack of common access interface. So we have a beautiful store, it's beautiful designed, it's updated like a charm. We can verify that it's true on every step of our application lifecycle, but we lack of this simple access interface, how to extract data from it. So here comes the selectors. Usual response that we have in our world of UI, I don't know, world of web development, it's a selectors. So how selectors look like? It's just as we have all the states and we create a bunch of functions that can access state for us, and now we call these functions. So it's a very simple jump in abstraction from the accessing raw state to it. So how selector does look like? So selectors is just an extension of state. So it's just simple function on top of state. For example, a first function can provide you top actor for some movie. So it will do all the dereference, all the accessing, all the chaining, all the parts together, while you can just call this function. Or for example, top movie entities will do this like compact map for the movie by ID and reference the top movies list to the movie by ID. And for example, last selection is a full name. It's a nice reusable piece of actor information that we want to access. And while with raw state access patterns, we have all these IDs all over the place and all the logic, we can improve it a little bit using selectors. Now we can access the functions that will do some kind of reused logic, and we basically simplified our selectors and connectors a little bit. What is the pros for this? It's pretty much simple. It's just another extension. You can do it anywhere you need. It's isolated. It's functions that will receive something and return something. It's acted directly on state, and it can be used for reduce, for example, if you need this information also. But its downsides. First of all, it's just a function, so basically anybody can write it anytime they want. So usually when you need to write a code, you don't know, do I need to write a selector or do I need to use it like as is? What should I do in this situation? It's pretty much unclear. And other problem, we need to pass IDs still as explicit parameters because we don't have anywhere to store a context. And I see the main problem of selectors as a lack of shared structure. So we have a lot of access patterns, but they lack of structure. They're not connected with each of other. So here comes a graph system, and basically this evolution of the selectors problem as I see it. First of all, we have the selectors like a extension of state, but with a graph system, we expanding this to be the wrapper of state. So now you never access state directly. You cannot access state directly if it's important. You can also access it using the graph system. What is a graph? Graph, as you know, it's a collection of nodes and edges. So we can have multiple nodes in it. We can have cycles in it because it's not real data. It's not storing the data. It's just interface on top of some data. On implementation level, graph, it's dumb simple. It's just single structure with single property which will contain state, and inside this graph we have nodes. Nodes on a graph is our domain entities. For example, movie is a node in a graph, so structure movie will have a link to a graph, some position coordinate to it, ID, and for example computer property title, which allow us to access information from the state. So as you can see, entity of the movie is also like helper property, which will go to the state and extract the entity to the graph, while title allow us to fetch title directly. And we have some kind of entrance to the graph. It's called like node edge without a node. So top movies. It's just a function on a graph that we can call and return a set of entities. It's important for graph to always stay inside a graph. So all the properties of a graph should relatively keep you inside of a graph. No need to call, no need to fall back to state. You should duplicate these interfaces. And edges is like relationship between entities. For example, for movie, we can add edge for all actors, which will be still the actors node. And you go to the state, you map everything, you create a special entity graph actor, again node. Everything of this happen inside the graph. And actor can have, for example, entity for all the movies. So we can have all this little nice circular movement inside the graph, which you can traverse. Let's look at the evolution of our usage of our system. So using selectors, we can only provide so much. So we still have IDs somewhere. We still need to perform a little bit passing around, but using graph system, we can express our thoughts directly. So this is the main selling point for me, that we can express our thoughts directly. And if we will build a mapper from graph to the props, we can usually find the code we expect. So we can graph top movies, we map every movie to the props version of it, then we extract title, and then we go to the link for the movie actors first and full name. Because we are inside the graph, we can go from actors to other movies and, for example, show how popular this actor is, how many movies they are participating. So this actors first movies count, for example, will be. This directly expressing the domain transformation is what makes graph idea so powerful for me. As I said, graph system contains from nodes and edges. It also allows us to have cycles, so we can move. Because graph doesn't store any actual information, it only serves as a layer of computation on top of like common interface on top of normalized state, it's never will be out of sync, so it's never will be showing you incorrect data. It's always will be just useful access pattern for the state. Also, graph may be useful if you will decide to add some mutations to it. How it can be done? So first of all, our graph can have dispatch function. Dispatch function will receive any action and just return nothing, because all changes to our system are like unidirectional and we don't know which change it will cause. But using this, we can add, for the movie, for example, we can add function watch, which will itself trigger graph dispatch some action with some like ID encapsulated inside in it and some details. So basically we can encapsulate not only the access patterns but also mutation patterns. So we can have functions, we can have computed properties, and this creates that we can use graph as the only interface to the state in our system. So pros of this is basically ID support for me and the model mappings. What I mean under this, that we will show it exactly like it is for the exactly like it is for the sake of our how we imagine the transformation from our domain go to the several different points of our system. It will be exactly like this, and we can model it to be exactly like this, so we're not limited by how it's better to store, how it's better to we don't need to choose. We can have multiple interfaces, we can have multiple properties. This will provide the same data, shape it differently for different consumers. So graph itself allows us to have freedom of expression while encapsulating how it's stored and how it's implemented. The downside of graph is, of course, code duplication, as you can see on the first side, that we need to create second layer of entities on top of our entities, and need to write them by hand. We tried and experimented with code generation multiple times. It doesn't end very well, because if you can project it one-to-one, it still like doesn't feel and understandable what value it will bring to you. So usually this layer is written by hand, but it's grow as quick as grows your application, so it's just encapsulated in the development of the features itself. Now I want to go to the questions section, and I have usually the first question on this topic: is it like ORM in our core data, like invented on top of Redux? Basically, yes, it is. While we can see Redux at, I don't know, as a normalized database in memory for all our data, we can see this like normalized and in-memory ORM, which will much simplify it compared to other ORMs, mostly because you don't care about the access, you don't care about the performance. You can, everything is in memory, you need just to compose everything together and provide beautiful interface. So this is basically ORM, yes. If you have more questions, you can send me to email or follow me on Twitter and ask here. And of course, we will go to the backstage and I will be able to answer more of your questions in a moment. Thank you again for coming to my talk. I hope it will be helpful for you and it will inspire you to bring more like isolation to your products and try to increase the clarity of your work. Thank you. See you soon. Bye.